Hey guys, part one video for section 10.4. We're going to start off by looking at the graph of an exponential function versus a logarithm function. So, hey, we have been telling you from day one that if you want to graph something, one way to do that is to just essentially make one of these, to make a table and pop numbers in there. So I'm just going to start. 0 is always a good number to plug in. So if I plug 0 in right here for x, anything to the 0 power is 1. You could use a calculator to check that out if you needed to. I'll plug in 1. That'd be 2 to the first power. That'd be 2. If I plug in a 2, 2 squared would be 4. Going to go with the 3. Plug that guy in. That'd be 8. So let me graph some of these guys. So we got a 0, 1. We get a 1, 2. We got a 2, 4. And we got a 3, 8. So I guess the question is, what's happening on the other end of this graph? So he's diving like this, and then what's going to happen? So let's try one more number. So if I get -1, well, if I plug a -1 right here where that x is, that would say 2 to the -1 power. And way back, we talked about negative exponents means you move it to the bottom. So right about there, and then I'll just go ahead and tell you they're going to get smaller and smaller and smaller as you go. That, ladies and gentlemen, is known as an asymptote. So that guy's getting really, really close to that x-axis, but not going through it. So, did we talk about inverse graphs? We most certainly did. Inverse graphs can be done simply by flip-flopping the coordinates. So I'm flip-flopping that first one. How about the second one? Third one. Fourth one would be 8, 3. And then I'm even going to flip this last guy. So we'd have a 1/2 comma -1. So graphing those guys, I got a 1, 0. I got a 2, 1. I got a 4, 2. I got an 8, 3. And then this guy right about here. Now think about it. If the original graph has an asymptote of the x-axis, what do you think the odds are of the inverse graph having the y-axis as an asymptote? And that's exactly what happens. And just to prove it to you, we did learn about this 45-degree symmetry line, y equals x line. And if you take a peek, I would hope you could see the symmetry on either side of that. So that's just a little quick overview of what the graphs for these guys look like, and the fact that we're about to talk about a log function. A log function is literally the inverse of the exponential function. So blue one exponential function, red one log function. I assume I got those colors right because you know me, I'm colorblind. All right, I'm going to scroll down here and take a look at the actual equation stuff. So here's what we just got done saying. Here's the original problem, which was exponential. The equation form, remember, we would flip the x and y around, but that guy right there and this guy right here are the exact same thing. But I guess what's important out of that, to at least give you some terminology, so if you notice the y right here in this guy is the exponent. So where's the exponent end up with when you write it in log form? The exponent would be right there. I hope you guys remember that the 2 here, the big guy, is called the base. And even though they don't have a 2 written here, we're just giving you generic form right there, that little guy. He's the base. So that's where that guy goes in the problem. And then if you want to call this guy over here the answer, right? So this is sort of the answer to raising a number to an exponent. So the answer is right here. And I used to call it the answer until Mr. McConnell told me the correct terminology for that. And it's called the argument. So anyway, that's the pieces. So let's take a look at some problems, and that'll help you out as far as knowing what goes where. And it's really actually a pretty easy process. So this first one, what we're doing is the direction is telling you to change from logarithm form into exponential form. So in math, it's always a good idea to be able to go back and forth with things. Sometimes one route's a good way to go. Sometimes the other route is a good way to go. So the little number is the base. In an exponential form, that means the guy that's being raised to an exponent. The exponent is down here on the end. That's a terrible 0. Imagine that's a 0, guys. Equals the argument or the answer, which is right there. So that's what the exponential form of that same problem would be if you weren't sure, if you were taking a quiz, like, do I have these in the right order? Hey, you could actually put 8 to the 0 power in a calculator and see if it equals 1. And if it does, guess what? You got it in right form. So over here, I know this sounds weird. The little number is the base, and it ends up being the big number down here, so exponential form. The exponent's down here on the end. The argument is the answer. Type it on a calculator. Put 2 to the negative fourth on there. It's going to tell you 1/16. So I'd like to think you're imagining this is not too bad. It's a memory thing. Base is 3. Exponents on the end. The answer is the argument. And that's it. That's just converting from logarithm form to exponential form. Well, you know darn well, if we're going to make you do logs to exponents, we're going to make you do exponents to logs. Well, might as well go ahead and do this, right? So if I'm changing the log form, these guys are all going to have the word log in it. All right, the base for an exponential is that number right there, the number being raised to a power. The base becomes the little number. Big number, base. Little number, base. Big number, 125. Little number, 125. So the argument is what goes next, and the argument is the answer in the original problem. So the argument goes next. The argument goes next. The argument goes next. And when you're changing the log form, this sounds crazy, but the exponent's the answer. Exponent. 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 Done deal. So again, kind of a memory thing, right? Once you get that memorized, you know what goes where, and there's only 3 parts. Well, it becomes pretty darn easy. All right, third one. So we're going to solve some problems. Evaluate, it means find me a number, find me an answer. So if you notice in number 7, it's got kind of 2 of the 3 parts. It's got a base, which is a 3. It's got the 81, which was an argument, and it's missing an exponent. Well, as far as equations go and solving equations, you can always stick an equals x on the end. So, hey, log base 3 of 81 equals what? Equals my answer. So what represents an answer mathematically when you don't know it? You put an x there. So convert it. If you start off with a log, base, exponents on the end, argument's the answer. So that's setting it up. Now solving it's a little tricky. This is kind of cool. If the numbers on both sides, if the 3 and the 81 matched, you would be able to eliminate them or cancel them. It's called the equality property. So all I have to do is figure out what I can change 81 into as far as 3 to some exponent. So you could fiddle around on a calculator with this, and you would eventually find out that 81 is the same thing as 3 to the 4th power. So here's the beauty of solving these guys. I get to cross those off. So as long as my exponents match, they must be the same value. X equals 4. So down here, put a y this time just for kicks, doesn't matter. Base, exponent, argument. So the question is, 256 must be 4 to the some power. Well, coincidence. Didn't mean to make an exponent of 4 twice, but 256 is 4 to the 4th power. I get to cross my bases off. That's a y. Poor choice, looks like a 4. Equals 4. Done. Pretty easy. Last one a little tougher. I'm going to use x again. So again, base, exponent, answer. So I've got to figure out 32. That's 2 to the what? Well, it's 2 to the 5th. But it is on the bottom, guys. So, well, it's just the negative exponent thing. If I were to yank him back up to the top, negative exponents go to the bottom, move them back to the top, it's negative. Cross the bases off. X equals -5. All done. Not too bad with those guys. All right, so we'll pick this video up, or this series of videos with part 2 for the rest of the notes coming up. Thanks for watching.